Well, good evening, everybody. Welcome back to another exciting episode of CS 410J Advanced Java Programming here at Portland State University. So in week 3, let's see here. First, we'll start off with some Q&A. I want to find out how Project 1 went. Then we'll take a look at Project 3. And as you notice, we're starting getting one project every week, and so things are starting to come fast. And then we're going to dive into what we're doing tonight. What we're doing tonight might be a little different for you guys. Tonight, in weeks 1 and 2, you saw me code, you saw me and Sean code, and now it's time for you guys to code together. And so what we're going to be doing tonight is leveraging this really cool classroom that we got to do some mob programming and some pair programming. To give you guys an opportunity not only to sharpen and use your Java skills, but also work together. Then we'll talk about what your experiences were like, good and bad. So let's dive into it. Project 1 was due. How'd it go? Saw some good questions on the community and stuff. I'm seeing some noddings. Any questions about what you did? Any feedback for me on Project 1? Yes?
I think you've got some of your specifications are in different multiple documents. Like how to submit a project tells you that -readme should have some very specific functionality, whereas in Project 1 doesn't talk about that.
That's a good point. Yeah. So the README is described in the README document, but there's also something in the submit about. Yes. Okay. Good to know. Thank you. Could you post that to the Google Plus group, and then that'll give me a trigger to go create an issue off in some GitHub repository, so I can fix that for future students. Thank you. That's really good feedback. I appreciate that. Anything else? Okay. Yeah. Is it possible for you guys to get input and output like in Project 0? You mean to use that test class to? Okay. So right. So for can I provide examples of for this input, what should you get for output? Yes, and I'd prefer to get those as questions to the community. So I'm kind of reluctant to say, hey, here's all the inputs and outputs for you, because then what grade you want? I think part of the assignment is thinking creatively about test cases and stuff. But and actually there was a question, I don't know if it was on Project 1 or Project 2, it was Project 1 that somebody asked about the extraneous command line arguments. Kathleen, was that you?
Yes.
Okay. Oh, sorry, you're Kathleen.
No.
Okay. Yeah, I was going to say, yeah, you're Kathleen, right. Right, and I thought that was a great question, because it's okay, well, I'm thinking of this test case, and I'm not too sure what you're supposed to do. And so ask, and I'll answer. So I think that's a good way of doing it. Yeah. Cool. And then when Sean grades your projects, you'll see all the test cases that we use. And if there are any that didn't pass, I recommend that you get them to pass, because they're very likely to show up with Project 2. Because the functionality doesn't change that much. Speaking of Project 2, there's already been some good questions about it on the forum. What are people's thoughts on Project 2? Questions about the specification, about the implementation? It's too hard. No, I hope it's not too hard. Yeah?
Can we just use straight serialization?
Can you use straight serialization? No, because I want the text file to be a text file. And so part of it is that's got to be human readable. That way we can, Sean, can determine things like, okay, I added another phone call. Did it really get added? If it's just a blob, there's no way in this assignment to be able to say that. So please, I guess the requirement is that you can use whatever format you want as long as it's a text format, not a binary format. You can serialize to XML or something like that too if you want to play with that. But anything else on Project 2? Cones. Haven't forgot about those, I hope. So they're due when? A couple more weeks. So you should be probably more than halfway through, because there's more assignments coming and stuff like that. Yes?
I have a question about some of the things in the code. It'll show me that my expected is the same as what the test case, I guess. Mm-hmm. But it's showing that there's still an error.
Oh, interesting.
It'll display the same output, but it's the objects are not.
And I'm not sure if it's expecting a function call or something
It-
I wish I turned the break because
Yeah,
some
or post something about it to the community because it sounds like other people might have got across that too. So yeah, I mean it's possible. You have two. So it's the cone is comparing two objects, and it might be that the two-string value of those two objects either is the same or looks very similar, but underneath the covers it might not be exactly the thing. Yeah. Yep.
If that problem you're running into is in the file I/O section, there's a fix for that posted.
Right. Yeah, that's a good point. Yeah, we have found a couple of bugs in the cones. Yeah, and yeah, that one in particular. Gee, I guess I still haven't bugged the cones guys about it. Yeah.
I think there was at least one where the comparison thing was in the opposite order from all the other cones.
Oh, really?
So like what we expected to and actually saw
Mhm.
thing shows up in reverse. So I usually even went ahead and switched that, but that'd be like a problem.
It won't be a problem. And if you could point that out to me, that'd be cool because I fix that kind of stuff, right? I mean, if you come across problems or things like that, please raise them up for your fellow students and then students of the future. Okay. Everybody's wearing like silver hats and stuff. No, it could be like Back to the Future 2015, right? It could be like Biff's grandson or whatever with that spiky hat and everything. Anyway, my 8-year-old is really disappointed that this is the year 2015 and there aren't flying cars and flying skateboards. It's like it's just a movie. Anyway.
Like metal broke.
Yeah, right. It is. Okay. Anything else on Project 2? Nope. Let's take a look at Project 3. Okay, so in Project 2, we took the phone bill application and we added the ability to write it out to a file, a text file that was written by your program and is read by your program. It's not meant to be human readable. It's not meant to be pretty. Well, in Project 3, we're going to make a way of pretty printing a phone bill and the contents of the phone bill. And so you're going to add functionality like sorting to it, and then also text formatting. And I recommend that you leverage Java's APIs for doing this. So this is meant to reinforce some of the stuff that you learned about in those in sort of the second part of the Core I/O screencasts. Things like using collections and then using date format and things like that. So some new functionality that you'll need to add. Now this is the assignment where you have to use Java util date. And so then, date is a class that represents, dates. And so as such, you should override the get start time and get end time methods that you inherit. The ones in the abstract class just return null. Well, you should have them return a date, the actual date that represents the start time and the end time. You should also re-implement your start time string and end time string methods to return strings that are formatted using the built-in date format.short. And if some of these things aren't looking familiar to you, go and watch the screencast because it's all explained. So you'll want to use date. Also, in this project, phone calls should be sorted chronologically in the phone bill. So when you ask a phone bill for its phone calls, they should be sorted chronologically. Chronologically by their begin time. And so then we'd figure out how to resolve the tie. If you have two phone calls that begin at the same time, then they should be sorted by the caller's phone numbers. And then phone calls that begin at the same time and are from the same caller should be considered equal. So that's like all the sorting that you need to do. I highly recommend that you implement this sorting by making your phone call class implement the comparable interface. Comparable is consulted by collections like TreeSet, and so it'll automatically sort your phone calls because they have what's called a natural order. Also, in this assignment, I'd like you to implement another implementation of phone bill dumper that dumps a phone bill not to a text file like your text dumper does, but now this one's called Pretty Printer, and what it does is it converts a phone bill into a nicely formatted textual representation of it. And nicely formatted is kind of in the eye of the beholder, but I recommend that you use date format or some of the new APIs in the Java time package to make the dates look nice. So this is your opportunity to sort of play with and experiment with Java's date formatting capabilities. And note also that the pretty printer should include the duration of each phone call in minutes. So any questions about the new functionality to add? Oh, all seem reasonable.
It says for pretty print the to text file or to standard out.
Oh.
How do they?
Yeah.
How does that differentiate?
I'll come back to that in just a second. That's a good point. So down here in terms of what you need to do in the command line, now you have a Project 3 class that drives all of this. Note, the arguments are the same 5 arguments that we've had all along. And there is a new option called -pretty. And following the -pretty option is the name of the file that you'll pretty print to. Or if the file is dash, this is like Unix commands, it should write to standard out. So he asked, wait, how do you do that? Well, I'm not going to give you all the answers, but what you should do is you should have your pretty printer abstract out the destination to where it's writing to, and then have the thing that calls the pretty print or creates the pretty printer decide where it goes to. So like really, so like the decision in terms of, well, should I pretty print to a file or pretty print to standard out, that decision should be made probably in your main method or somewhere in your main program. And then the pretty printer doesn't really care where it pretty prints to. All it knows, all its responsibility is to figure out how to pretty print a phone bill. Vague enough? Enough clues? Yeah. Okay. Cool. And let's see here. So a couple of notes. The phone bill should be pretty printed after the phone call has been added, meaning that let's say you have -pretty and -text file. So you read the contents of the text file, you add the new phone call to it, as specified on the command line, and then you print it out. So it should contain all of the phone calls, not just the ones that were there in the text file before, but also the new one. Note also that the command line syntax has changed a little bit. Phone numbers are still the same. But now the date and time format is no longer 24-hour time. Now it's AM PM. So a valid date and time would be something like this string right here. So these are 3 command line arguments where they used to be 2. And I also encourage you to use Java's date formatting and date parsing capabilities to convert these 3 command line arguments into a Java util date. Let's see here. Error handling, graceful exiting, and so actually, it's all the same stuff. But for instance, hey, maybe your command line is wrong, or the format of the day and time is incorrect. So that's Project 3, due the 22nd, which is what, 2 weeks away, right? So, what was that? Project a week plus cones. Yep. They don't call it advanced Java program for nothing. I don't know. Yeah. Okay. Cool. Yeah.
Well, since these projects are building upon one another and you're only looking basically at the output and you're not examining our code for the grade. Right. If we just have bad coding habits starting with Project 1 and keep building on that, it just gets horrendous. Can we request like a code review or something like that?
Yeah, I mean, if you really like.
This right or not?
Yep. Yeah, you can.
You know, get it to work and produce the output that you want, but maybe that's not the best way to be doing it.
Yep, I'm open to it. I don't know if we could do like 40 of them, well, like for instance, if you're using a private GitHub repository and you want to add me as a collaborator, I'll be able to see it and I'll be able to comment on it. So yeah, I mean, if you'd like, I'll try my best to give you guys feedback. You'll probably also know yourself if you're getting to like Project 3 and it's like, oh, this code is a mess. I've got 10,000 lines of code, right? And so you can probably also sort of self-regulate that. But yeah, I'm happy to provide feedback, and probably a private GitHub repository is the best way to do that. Cool. Okay, Project 3. Okay, now let's talk about some stuff. Okay, So as I said, I think I introduced on the first day, a couple years ago I decided to stop lecturing you guys and start interacting with you guys. So you can watch, me pontificate about the wonders of Java on the YouTube, and here let's work together. And so tonight we're really going to start that in earnest. So what we're going to do is, for the rest of the class, is dedicate most of class time to performing what are called code katas. So a kata is a little exercise, bigger than a cone, but it's like a little programming exercise which is meant for you to practice and sharpen your skills in coding. And so I guess I've got a couple of pages here. I was looking for a definition of a kata, but I guess it doesn't really give it here. And so then we'll be going through little programming exercises, and we're going to do it working in groups. I'd like to simulate in here something called a coding dojo. So in karate, a dojo is where the karate lesson happens. I don't know what I'm talking about. I've never taken karate, which I'm sure you couldn't have guessed. But the whole idea is that it's really group learning. It's an individual being taught, and the group learns. And so and I think it's actually a pretty good environment for learning. So I'm going to watch.
So what is
a
coding?
Oops, let's make it full screen so everybody can see. So here's a little video that explains what a coding dojo is. And then we'll see, well, let's watch this and we'll talk some more.
So what is a coding dojo? Well, first off, the most important part is really the setting. So if you imagine the setting to, of course, have a single computer, it's attached to some kind of projector, and of course that projector is projecting up on the wall here. And then the other important part is to have a secondary space, usually a whiteboard or a flip chart, where the problem and ideas can be written up there. Along those lines, of course, you've got two pair programmers or spars who are working together, a pilot and a co-pilot, and then you have the dojo participants who are sitting around, usually no more than, I'd say, 12 to 15 people. Okay, so that's the setting. Now let's go on to the people, the roles, and it's important to note that all of these roles have to actually have someone in place at all times and acting as responsible for the job of that role. So, role number one is the sensei. As you can see here, there's no sensei listed, and that's because usually the sensei is somewhere off in the distance in the background, watching and guiding the dojo, not giving instructions or solutions, but rather pathways to the solution. Remember, there is no spoon. Okay, number two, pair programmers. These two people are the spars. One of them is the pilot, so one of them is typing, and it's their job to write down the syntax and start to throw out ideas in a way to be on the offensive, to be the attacker, and to get the ideas up on the board so that the rest of the people can overlook at it and provide other solutions. The other person, the co-pilot, the fellow pair programmer or spar, their job is to look over the other code that's being written by the first spar and to kind of be on the defensive, to try to help and suggest ideas and to kind of quietly whisper in the ear and help the first person. It's very much the idea that these two people are working together. They're not fighting. They're training one another to be able to do the best job in the same way that a kata would be performed in karate. Finally, other than your two pair programmers in the middle, are kind of the advisors. Now, it's really important to notice that all of these people that are around the room, they're all participating at the same time. Oftentimes, they'll hop up and they'll write on the problem board themselves. They'll shout out answers if they see something done differently by the primary pilot programmer. And then the other important thing to notice here is that everyone has to take an opportunity, a chance to be a pilot and a co-pilot. So you'll very much have people switch out and to take their opportunities. Usually about 15 to 20 minutes, someone will sit in the pilot and co-pilot seat, and then switch out. So usually you'll take your first go as the pilot because you'll need to learn how to type the syntax. And then once you're kind of getting the idea of how to type the syntax of the code, you'll have the second co-pilot who can then swap over and help advise the new person coming in. So everyone in the entire programming dojo must participate. Which brings us to the rules, actually. So let's go on to the rules of the coding. So now let's go to the rules of the dojo. So one of the most important parts is, number one, the sensei asks questions, does not give answers. And so the real point about the sensei, who's obviously kind of somewhere in the background to this activity, is just providing guidance. There is no spoon. They're just teaching you how to move forward. Often the problem that they give, or the challenge they give, is given beforehand, usually a week in advance by email, so people have time to think about it. All right, rule number 2. All must participate in code being written. And what it means by that is that all of these participants around the edge who need to take their turn in the middle at some point, all of these people need to be watching the primary coding board. So what's going on with the two sparring partners and what they're writing. They need to be looking up here and participating, and ideally helping contribute by suggesting solutions. They should not have their own computers out. Not really. They should be, unless they're trying to look up stuff or something else. I mean, there's no strict rules, but ideally they're not coding by themselves. They're trying to team code and help this person learn as much as the rest of them will have help themselves when they code. Finally, rule number 3, everyone must participate in sparring, which means that everyone must take their turn as pilot and co-pilot in both typing and also helping teach how to type. So this person, this person, this person, this person, this person, so forth and so on. Every single person should switch out at some point, come and take their turn to type, and then swap out and take their turn on helping to advise and all the rest of it and give solutions. So that, in essence, is the Coding Dojo. Cheers.
Thanks, Internet guy. Okay, I don't know. Stop. Autoplay. So that's the Coding Dojo. It's a learning environment in which you've got a pair of coders who are whose IDE whose IDE is projected up for everybody to see, and so that's a tool for learning how to program. There's also an emerging programming practice called mob programming, which is doing something similar professionally. So this is a video that Woody Zuhl put together with his actual programming team, and it sort of fast forwards through the day, and you can see how you've got not just two people pairing to put together a program, but you've really got a group, a team, all working together, all looking at the same code, all interacting with each other to write code and to build an application. So let me get this started. I don't think there's any audio in it. So the whole idea is that it's whole team programming, and so here you start at the beginning of the day. You're maybe doing some skill learning or whatever. So I think this is an opportunity where maybe one member of the team has it's sort of a teaching thing. It's like, hey, maybe there's a new language, or hey, today we're going to use this new library. Here's what here's what it is all about. So in their environment. So single computer with two projectors. Not too sure why they have the two projectors. Maybe it's just so that everybody can see, or so you can have some people comfortably looking at each. So here it's similar to pair programming in that there's a driver. The person at the keyboard is actually typing, but instead of one navigator, you've really got a group of navigators who's keeping their eye on the code, who is advising the driver in what to do. So here, they're 10 a.m., they've already delivered a piece of functionality, and they've all worked together on it. The driver rotates every 15 minutes, and this is important. It's called a randori. There's an example of someone takes a little break, goes off, and does an expense report or whatever, and then comes back. It's important that the driver switch every once in a while. Because the driver can get tired. You don't want to have someone who's hogging the entire thing. And everybody takes a break for lunch. Very important. And during lunch, coding stops on this, right? People go off and do their own thing. They eat. This guy's checking his email or whatever. It's not very interesting. We really didn't have a clock. Okay, Woody comes back. The rest of the dudes come back. Okay. And so here we go again. There was someone else who was around, and that was the product owner. So the product owner is the person that will. Okay, maybe that wasn't the product owner. Anyway, the product owner will come in and out, and periodically look at the progress, look what's done, and the entire team's there, and so they can very easily show off what they've done. No food coma. So that's a very interesting point. So because the entire team is there, you've got all the expertise right there when you need it. So it's not like you need to send someone an email wait for a reply. It's not like you even need to go up and walk over to their desk or just look across the cubicle wall and distract them from what they're doing. The whole idea is that in mob programming, everybody's focused on the same thing at the same time on the same computer. I think one of the things that mob programming purports to offer is, well, at the end of the day, not only do you end up with with working, functioning software, but you've got an entire team of people that know everything there is to know about that software. So one of the things that I've combated a lot professionally is sort of siloing of knowledge, right? You get to some piece of code and it's clear that it's like that's one person's piece of code or one person's like submodule, and so then it's really hard to attack. And boy, when that person leaves the company, you're kind of out of luck. So what this again purports to offer is just spreading the knowledge because everybody developed it together. Yeah.
Do you typically get as much done in mob programming as individuals or pair programming?
They would say definitely more than individuals, because what you don't have is the one person going off in the one direction and it's the wrong direction. And I think what they claim, and so evidence can bear this out, is that what you end up with is a much more resilient. Not only more resilient product because you've had so many eyes on it, but also a much more resilient team to be able to support that product. And so then, when one person goes on vacation, really the team doesn't lose a beat, and they've got all the context that they need. That's what they claim anyway. So I haven't tried this professionally, but you're going to try it, my little laboratory. Anyway, so tonight. So that's the kind of environment that I'd like to work in this classroom. So we've got on the two sides of the room, we've got these 4 projection systems, and I think you can plug your laptops in. Looks like they have VGA, maybe HDMI. And so I'm going to introduce our first coding kata, and then let's move some furniture. So
We want some on the sides and
yeah, well, I'll talk about those details. Yeah, after we introduce the kata. So okay. So this is a little kata that maybe some of you have heard of. It simulates a little counting game, and so the way they tell the story is that there's a teacher that decides to teach about modular calculus, whatever it's called, modding numbers, and so the kids go around the room and they start counting off. 1, 2, 3. And if you've got a number that's divisible by 3, you say fizz. And if it's divisible by 5, you say buzz. And if they're divisible by both 3 and 5, you say fizz buzz. And this is the program that you write as part of this kata. And so you want to write a program that prints the numbers from 1 to 100, and then plays this fizz buzz game. So numbers that are divisible by 3 will print fizz. Numbers divisible by 5 will print buzz. And when you have both, you'll print fizz buzz. Oh, and then there's also the second stage for new requirements. I think this is a good opportunity to practice test-driven development. So as you can imagine, you know, you can write some tests to make sure that at a unit level, so for a given number, it prints out the or returns or whatever, prints out the right thing, and then you can build that up to the final program, which prints all of the numbers 1 to 100. Any questions about the kata or how it works? Okay. I've had students tell me in the past that it's like, oh, I interviewed for a job once, and they asked me about this FizzBuzz kata thing, and so who knows, you might see it again in a job interview. Let you do a couple of things. So, and also I haven't introduced you to the keyboards. So, when I realized the first time I did the pair programming, I had people just share laptops, and I'm like, yeah, you know what? There's like SARS and MERS, and like I don't want people getting sick and stuff like that. So, and also it's like someone that you barely know who maybe just went to McDonald's or something, you don't want them touching your keyboard. Completely understand. So I asked Warren, hey, can you scrounge up some USB keyboards? And he said, sure. And so then he got us this nice set of USB keyboards plus this really nice cart. Anyway, and so we've got 10 USB keyboards. Oh, 20, that's right.
2 in each.
Okay, I forgot there was 2 in each. Awesome. So we've got plenty of keyboards. However, we've only got 4 stations. And I think in terms of the mob, let's max it out at like 5 or 6 people. So I don't think everybody's going to get to be in a mob, but that's okay. Let's have tonight some people, so we'll have mobs around the stations, and then in the middle of the room, we can have some pairs. I'll encourage you guys to in a moment, we can all self-organize, figure out who wants to be in a mob, who wants to be in pairs, move the furniture around, so that people can be at the stations, and the people who want to pair can be in the middle or up here. And I guess one more thing. To get started, I recommend that you use the archetype from Project 1 to create yourself a little Maven project for this. And then, where's Project 1? You can just use the Maven archetype for Project 1 to generate something that looks a lot like your phone bill application. You won't need all the phone bill stuff, but what you will need is a Maven project. It's probably the quickest way to do that, and just start renaming things. So you don't need to have a Project 1. You can have your FizzBuzz Kata class, wherever you want to call it. And let's see here. And so Sean and I will be playing the roles of the Sensei and go Mr. Miyagi on you because my car is dirty. I need it washed. We'll get some experience. Okay, so we'll get some experience doing the kata. And then I'd like to see what some of your solutions are, and so I'll create a Google Hangout that you can join and share your code with everybody else. Sound like a grand experiment in software engineering? Yeah, whatever. Okay, excellent. Okay, so I'll pause the recording, and then let's get the room set up.